Good morning, welcome to day 19 of Advent of Code, where I try to solve the Advent of Code puzzles. Today we don't have enough minerals. Your scans show that lava did indeed form obsidian. Okay, so we exit the cave with the elephants. We have geodes around the pond. Can we use obsidian to create some geode cracking robots and break them open? We need waterproof obsidian collecting robots. That's good, we can make the robots waterproof. We need special purpose clay collection robots. We need ore, which is also plentiful. Collecting one ore requires ore collecting robots. Okay, so we have certain blueprints. Looks like we're doing a planning problem today. Each robot can collect one of its resources type per minute. It also takes 1 minute for the robot factory to construct any type of robots. It consumes the necessary resources available when construction begins. We have many blueprints you can choose from, but once you've configured it with a blueprint, you can't change it. Okay, so we have a set of blueprints, and then we need to figure out which is the best. Luckily, we can do that. Day 19.txt. Let's move this to Visual Studio Code. It's interesting because the blueprint input here is different than the example input. That's weird. That's annoying. Let's just edit this then. So 1 ore robot costs 4 ore, clay robot costs 2 ore, each obsidian robot costs 3 ore and 14 clay. Each geode robot costs... why am I even editing this? Let's not do it here. For line in, let's import regular expressions. Costs is list. Let's extract the costs and add that. Cool. And for now we can say costs is this array. Why am I even typing this? It's so annoying. 1, 4, 2, 3, 14, 2, 7. But I love having unit tests, so 2, 2, 3, 3, 8. 2, 2, 3, 3, 8, 3, 12, 1, 4, 2, 3, 14, 2, 7. Perfect. Okay. So we have blueprint ID. Cost ore robot, cost clay robot, ops or ops clay, geode, or geode ops in costs. Okay, the elephant is starting to look hungry, so it shouldn't take too long. You need to figure out which blueprint would maximize the number of open geos after 24 minutes. Okay, so our goal is to get as many geos as possible. The largest number we can open in 24 minutes is 9. Let's say max minutes is 24. And we start with one ore collecting robot. So robots is 1 ore, 0 clay, 0 obsidian, 0 geodes. Ore, clay, and geo, obsidian, and geodes. Robots. Number of robots. Perfect. So in minute 3 we can spend 2 ore to build a clay collecting robot. All right. So let's do another breadth first search day, and then we can convert it into A star if we need to. So at the moment, I don't know if breadth first search would be okay, because we get a huge amount of we get a huge amount of states. So we get a certain amount of costs. And we of course have a start, num minutes. I don't know, it's not really search, right? It's just a tree. Search a tree. Let's see. Q is a list. State minutes. Let's see. State minutes is q.pop. If number is equal to, let's see, then we have max. What are we searching? Max obsidian, max geodes. So we also need num materials. This is a bit difficult to wrap my head around. So let's go back to the basics. What do we have? We have our robots. We have robots 4 types. We have materials, also 4 types, I think. No, well, yeah. Materials, ore, clay, obsidian, and geodes. 4 types. And the question is, current stack of materials, like current inventory of materials, total materials mined, also 4 types. Okay. So we have our robots. Let's see. We have a number of materials, I guess. I guess yeah, that actually makes sense to say we have 0, 0, 0, 0 materials and we mine 0, 0, 0. Okay. So then we've got our minutes and robots, inventory, mined is q.pop. Perfect. Max geodes mined is 0. If minutes is equal to the number of minutes, max geodes mined is max between mined 3. Right. So we need to determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened in 24 minutes. I can open 9. Yeah, okay. You add up the quality levels of all the blueprints in the list, you get 33. Okay. So then at the end we return max geodes mined. Perfect. So now the question is, what can we do? For each robot, try to mine. That actually sounds pretty good, because we first start collecting. What I don't understand is that we spent or to start building a clay collecting robot. Oh, and it's ready in the same minutes. Okay, so I guess I can just do mine ore with robots. Build new robots. Let's see. And all the robots always mine 1. Yeah, okay. So then inventory is yes. Perfect. And now we get a bit to the annoying thing of the costs. Let me take a look at what the input looks like. So this always costs 1. It's always ore and clay, it's always ore and obsidian. I guess we can just like try each of them. So we try building an ore robot. So if my inventory, if I have enough ore for an ore robot, then my new robot is, let's see, is, let's make it a list of robots. New robots 0 plus is 1. I kind of like how CoPilot decided that we would have a cost for each robot. That might actually be a really good way to represent the costs. We can indeed do it like this. So the ore robot would cost cost per robot is a list. Cost per robot let's not do it like this. Okay, I actually like it here. Never mind. So then cost per robot is, we make a list with the cost ore robots 0, 0, 0. The clay robot also costs ore, costs clay robots. The obsidian robot costs ore and clay. Forgot one S. And then the geode robot costs geode ore, obsidian, and nothing costs ore. Perfect. So then we basically call with the cost per robot our nice one robot max minutes. Okay, I have the feeling that this call is at least good. I wonder if it's fast enough, but whatever. So try building. Let's see, can we build more than one robot at a time? I guess, right? Can we really build more than one robot at a time? I guess there's a question for later. To do, can we build more than one robot? Yeah, good question. So then for if my try building each type of robots. These are, by the way, days where CoPilot is really useless. Like, it's just more brain work and wrapping your head around a problem than typing out a search or like tree search or something algorithm. So yeah, that's that. That said, so we got our costs. So yeah, if we can afford it, check if we have enough materials to build robots. We can build robots. Then my new robots is robots J. My new robots I plus is 1. My new inventory is a nice new copy of the inventory minus the cost for the robots. Perfect. So I append to the queue my new robots. Don't want mutable things in my search. And I guess need to update that as well. Okay. Mind 0 and 0 geodes minds. That's not good. looks like we are somehow not adding things to the queue. Oh, we of course didn't try to build anything like... We didn't try to not build any robots. Case of not building a robot. Oh no, new robots is referenced before assignments. We just keep our robots the same, with the same inventory and the new inventory and the new minds. Yeah. And now we see that this is actually quite slow. Let me remove the print statement. Depth is 0. Is larger than depth. Print minutes. Depth is minutes. Let me see how slow it is exactly. Okay. So now the question is, how can we add a heuristic to how good a state is, where I'm assuming that the more geodes we have, the better. Prune our search space. As I said, I'm assuming that the more geodes we have, the better. So we can do q.sort. How do we determine the quality? Key is lambda x. Let's say that Obsidian is the best. So if we have any so we only get to the geode cracking robots at the end. So that's really sad. But yeah, anyways, let's say that it's best to have minds. Yeah, this is really going to be mega slow. Let's also take a look at no, it's not super terrible yet, but also if we would have a heap, we could do this way faster, but we don't need one. We can just prune our search space. have quality heuristic states. So we have our minutes, robots inventory minus state, return. Let's say we have 100 times -3 plus or 1,000 times. You know what they say? One geode in the hand is worth 5 obsidian in the bush. 100 times -2 plus 10 plus -0. That maybe very greedily go towards having as many of those geodes as possible. Key is the quality heuristic. Reverse is true. Yeah, let's pick the top 1,000 and see if this works. Let's see. Print minutes. Oh, what? Continue. Okay, otherwise we keep mining. So with blueprint 1, we can. Oh, looks like I have a better answer than the than the computer has. Two robots inventory mines. Let's open this up and compare it to what we have. So we have 1 which collected 1 ore. We have 2 ore. So we actually keep our 1 robot until the end. That can't be right. Surely it would be better to build anything. And is the num_mind actually correct? What are we doing wrong? Let me see what's going on here. This is really useless or not. So we can have after 1 step, we of course mine 1 thing. We can have 2 ore. After 1 minute we have 1 ore. After 2 minutes we should have either a robot and 2 ore. That's weird. We shouldn't be able to have a second robot, I think. Do we? How can we have a second robot? It's nice that we have an extra robot, but that's not the idea. We start with one robot. Oh, okay. So apparently if we check, you now have 2 ore. Oh, you start building them at the start. Let's add the new inventory and the new mind. And then we have to check if the inventory is more than the cost of the robots. Let me actually rename this to old inventory, because then it's way clearer what we're having. If the old inventory was more than the cost of the robots. Yeah, okay, that makes sense. Let's see. Now we are underachieving. So something is going wrong. Let me print this again and inspect. So we start by having 1 robot, mine 1 thing, 2 robots. Either we can keep our nice 1 robot and have 3 mines, or we can have 2 robots with 1 ore left. We have 1 ore and collected a total of 2. No. We should always have a total of 3 collected. Okay, well at least there I found that bug. Blueprint 1 should not have 6 geodes mined, it should have 9 geodes mined. Why are we having negative costs? That's not okay. So we can have 4 geodes, or we can have an extra robots. But how did we manage to get negative things? Again, it's nice. I really appreciate it. Let me take this step by step. Our new inventory mines the things, and our new mind we always mine the thing. See what is going wrong. So the inventory becomes negative at some point. How can this become negative? Q.append, new inventory, new mind. That's all going well, I think. We have a cost for our robots. If we have enough materials to build the robots, according to the old inventory, then we can build the robots. We copy the robots, add one for this type of robot we want to build. New inventory is the new inventory. Oh. Okay, so we got 9 geodes mined for the first one and 24 for the second one, right? Better. Here, 12 geodes mined, all right. Determine the quality level of each blueprint by multiplying the blueprint ID number with the largest number of geodes that can be opened. Best quality minus 1. Best quality is the max between the number of geodes mined. Okay. The first blueprint has ID 1 times blueprint ID. So for part 1 we get... Oh, okay. So you have to add up the quality levels of all the blueprints in the list. Some quality is 0. So some quality plus is now mined. Part 1, some quality. Okay, 33. So what if we don't have this, then we should have 994. Oh! Yes! Rank 74 on the stars leaderboard. Guess who has global leaderboard points now? It's 27. I am proud of myself. I've been trying to achieve this for years. This is the first time I actually do it. Yes! Part 2. While you were choosing the best blueprint, the elephants found some food on their own. Okay, so now they have 32 minutes. So one of the elephants ate most of your blueprints. Only the first 3 blueprints are intact. You no longer have enough blueprints to worry about the quality levels. For each of the first 3 blueprints, determine the largest number of geodes you could open, then multiply these 3 values together. For each of the 3 blueprints, determine the largest number of geodes. Just determine the largest number of geodes you could open using each of the first 3 blueprints. Okay. You could open using the first 3 blueprints. What am I missing? Okay. So now we are doing 32 minutes. To number 3, Cost per robot mined, maximum is 32. Some geodes. However, okay, you no longer have enough blueprints to worry about quality levels. Determine the largest, multiply these. Products, geodes is 1. Times it's not mined. Part 2. That's not the right answer. Is not the right answer. Okay. What I'm wondering is how big this should be. Like, if we make this a bit bigger, then everything will take more time, but then we might get a better answer. Okay, I guess I'm dumb. Let's read this carefully. While you were choosing the best blueprints, the elephant found some food on their own, so you're not in as much of a hurry. You figure you probably have 32 minutes before the wind changes direction. One of the elephant ate most of your blueprint list. Only the first 3 blueprints in your list are intact. Let's do this again and check if that's okay. So we have 56 geodes mined. Blueprint 2 from the example is a bit better. 62 mined. You no longer have enough blueprints to worry about quality levels. Determine the largest number of geodes you could open. Multiply these values together. So in this case, it would be 56 times 62, 3472. Yeah. I mean, it's a bit lame to arbitrarily start raising this, but I think it's the only way. Okay, so now we get 5960. Let's actually set this to a higher number and check if it raises anymore. And again, I agree that this is the lame way. Surely there must be a better way to encode this heuristic, but at least we're not searching for everything. So I wonder in which universe it's it's better to not build these robots immediately, like to not immediately go for geode cracking. All right, rank number 2 in the stars leaderboard. I gained 69 points. Whoop 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 whoop. Who has leaderboard points? It is me, rank number 32. I'm quite happy with this. I'm quite proud of this. Leaderboard points for the first time. Oh man, what a day. What a day to be alive. Just in case if someone is interested, I did get leaderboard points in the past, but I think that was in 2017. And normally I don't wake up early in other years, so it's not like I really tried before. But I think there was one day in 2017 where I was like, okay, I am going to try my best, get leaderboard points this day. And so I got up at 6 sometime later in the month, and there was this problem where you had to move those radioactive things around. So it was like a search problem like this. But then the search depth was extremely big and it was very difficult to construct a heuristic. So I think I was programming for like an hour, 1.5 hours, and I was just completely stuck. And I like used pen and paper to look, okay, well, I guess this go there, that cost me this much steps, this should go there, that cost me this much steps. And so I basically calculated on pen and paper how many steps it should take, and then I filled in this answer and it was correct, and got me on the leaderboard. So there was this one day later in the month of Advent of Code where I actually got leaderboard points by solving the question with pen and paper. So this is the first time that I actually managed to get on the leaderboards using programming and Python and good thinking. Anyways, that's it for me. I hope you enjoyed this. It cost me 50 minutes today. I guess that's not that much of a time waste. So yeah, have a nice day.